Lesson 91, we're making graphs and looking at the equation of the circle. So it's a nice specific topic that we're looking at. Just breaking down, how we connect the equation to the circle as well as its graph. This is the standard form of the equation of a circle. It goes x minus h quantity squared plus y minus k quantity squared is equal to r squared. A lot of variables. It's on our xy coordinate plane, so therefore you see your x and y there. The nice thing is the h and the k, that's pretty similar. If we go back to the parabola, what did the h and k represent? Vertex, very good. What do you suppose the h and k stands for here? Well, it's the center of the circle. So there it is. Center of the circle is your h comma k. The radius is going to be r. And the thing that typically gets students is this idea is it's r squared. Therefore, let's go ahead and address it right away. This is 16, so what's your radius going to be? Yeah, it's going to be 4. Very good. Because 4 squared is going to be equivalent to that 16. What's our h value here? They don't give us 1, correct? Therefore, it's got to be what? 0. Okay, we could write it this way if we wanted to. And we could write this, the k value with the 0. And there it is. So again, if the h and k value is not there, it's going to be 0 and 0. What's our radius again? We said it was 4. There's 5 points that I'm looking for when it comes to the graph of this thing. First one is going to be the center. And then the remaining 4 points is going to establish just how, wide this thing's going to be, the radius. 1, 2, 3, and 4. 1, 2, 3, and 4. And before we move on any further, I think it's beneficial maybe to kind of break this equation down. If we define a circle, we define it as being at any point that satisfies the equation. Really, we can't say that this thing is a line, but instead it's really just a bunch of points. And when we get enough of these points together, they basically form this curve. Okay, it basically forms a solid line that just happens to be a curve. So we define it as the set of order pairs that satisfies the equation. And this form right here really looks very similar to what that we already know. Well, it's very close to Pythagorean theorem, am I right? A squared plus b squared equals c squared. Well, what's the connection there? Well, if we go to pick one of these points, say it's that point on that circle right there, and I'm going to evaluate where that point's going to be at. I'm going to look at this x value, and I'm going to look at that y value. And in terms of the circle, this hypotenuse is no longer c, but now it's just that radius r. X squared plus y squared equals that r squared, correct? And there it is. X squared plus y squared equals r squared. Okay. Center then just moves that a little bit. But it's basically the Pythagorean theorem and looking at where all those points land. For example number 2, obviously our h and k value are not 0 anymore. What's our h value? Positive 2 or negative 2? Yeah, per the definition, because it was a minus sign, if we take a look at it again, minus h minus k, it's always the opposite. Negative 2, positive 1. Radius would be what, Dean?
3.
Yep. -2, 1. So identify your center again. And then from your center, count the number of units to the left, up, right, and down. 1, 2, 3. Set of all the points that satisfy this equation. I know some of you haven't taken geometry. If you did, you should be very comfortable with this equation. But for those of you that didn't, did you see this in Algebra 1? Don't believe so. Okay. Two very basic problems, they're working with the circle. But now we get into some other different ones. We want to write the equation of the circle with the center of -3, -1, as well as a radius of 7. If we take a look at our formula, or the definition, for this particular problem, we actually have all the pieces to the puzzle, and we can just simply plug them in. What's my h value going to be? Yeah, so is it going to be +3 or -3?
Plus.
Yeah, it's always the opposite. Plus or -1? Yep. And if you want to, you can write it this way. I actually prefer to write it that way. That way it's more straightforward. Yes, this is my radius. But this is what the textbook will give you. So I suppose we better go with that answer. We can do the work to go back and say, hey, I need to take the square root of it. Equation of the circle with the center at -2, 4. And we also know that there's going to be a point on the circle at 5, 2. We have the center. The problem is we don't know what the radius is, correct? But we do know a point that's going to be on the circle. Therefore, what are we going to use to find that radius? Distance formula. Very good. Yep.
I didn't see that.
Yeah. Yep. Okay. Want to find the distance from the center to the point on the circle, which will give us our radius. So let's review this. I believe you did this in the warm-up. D is equal to the square root x of 2 minus x of 1 y sub 2 minus y sub 1. Again, what will this distance represent again? Radius, which is what we wanted. -2 minus 5, -7. 53 is obviously not a perfect square root. It's also a prime number, so we know we're not going to be able to simplify that. So it's okay if you leave it as the square root. Center we know is 2, 4. And now we have both pieces to the puzzle. X plus 2, y minus 4 is equal to the square root of 53 squared. Again, radius squared, so be careful with that. A lot of people just write down the square root of 53. And the nice thing is the square root of 53 squared is just simply what? Yep. And that's another reason why we typically write it as 53. Just because the square root of 53 squared is kind of messy. Somebody breaking in out there? Intruder? Devin, you gonna guard the door for us?
Yep.
You slow him down and then I'll step in. How's that sound?
Okay.
Counting on you, man.
I'll hold him out.
You'll hold it. Write the equation of the circle that has the diameter whose endpoints are located at 3, 1, 6, 3. Okay, so let's think about this. Given 2 points that fall in the circle, it tells us that the diameter is going to be formed from those 2 points, 3, 1, and 6, 3. Okay. So what are your thoughts? Well, Mr. Dorr has the midpoint formula up there, right? And why would we want to use that midpoint formula? Eventually we'll get there, but we actually want to use the midpoint formula to find the center, correct? Here's the endpoints that represent the diameter. I want to use the midpoint to find the true location of that center. So let's review what the midpoint formula looks like. Recall the midpoint formula, or a midpoint is an ordered pair, correct? So if we're going to find it, midpoint, again it's an ordered pair, x, y. Well, the x here value deals with the 2 x's. We're going to add those 2 x's together and then we're going to divide by 2. We are finding the average of them is what we're doing. Same thing with the y value. We'll take the 2 y values that they give us, add them together, and then divide by 2. So once again, 2 endpoints that represent the diameter. We're going to use this midpoint formula to find the location of what point again? Center. And then from there we can do our work. And a lot of you are saying 9/2. No, it is not a nice integer to work with. It's not an integer altogether, but that's okay. 9/2 and 2. That represents the center. Now what do we need to do? Distance between the center and one of those 2 points, right? It don't matter which one. It could be this one, it could be that one. Doesn't matter to me. And what are we going to use to find that? Yeah, distance formula. Could we find the distance between these 2? And then do what to it? Divide by 2? What would be the benefit of doing that? It's actually an additional step because you got to go and divide by 2. Maybe the benefit of doing that would be we could stay away from fractions because those 2 don't have fractions there. So if you want to, you can do it either way. Find the distance between those 2 endpoints, divide by 2, that'll get you your radius, or simply find the distance between this point and one of those two on your own. Without looking in your book, let's make sure we can do the arithmetic. Square root of 13/4. Not very nice, right? And that's okay. A lot of these at this level aren't going to be nice whole number integers. Just have faith. If you want to, you can go back and check your arithmetic, but everything should be good there. Therefore, x, we write the equation, center again was 9/2 and 2, so minus 9/2 squared plus y minus 2. And if we square this thing right away, square root of 13/4 squared is going to get us just simply 13/4. If you would like to write it as a mixed number, that is fine. Otherwise, I will take 13/4. Number of different problems that they can throw at you when it comes to the equation of the circle. They could give you simply the center and the radius. They could give you 2 points on the circle. They could give you the center as well as a point on the circle. Let's do C, E, and F.